So hopefully you're familiar with general graph transformation. I know the previous video is a bit worded, but hopefully this video is going to go through examples and it's going to be clear. So we're going to deal with the transformation of sine of x. The reason I picked it is just so that you would see how it would fit with an unusual graph. Now, what we're going to do is we're going to apply the transformations in a function type matter, so that if you want to know the input and output of the new transformed function, you have the new function in front of you. So first, we're going to do the reflection. The first one is the negative f of x, so a reflection. And what that's going to look like is you're just going to put the negative in front of your function. And my function is sine of x. Always copy down the function itself. So the transformation, the reflection on the x-axis is going to be negative sine of x. So if you need to know, what will be the new output for, let's say you're dealing with degrees, f of 3, so you're going to go negative sine of 3, and it's going to give you the new output. Now, if we're dealing with the reflection on the y-axis, your input is negative x. All you have to do is copy the input inside your function input, and that's it. That's what you're going to get. So, so this is going to be my new function now. So if I'm going to say, I'm going to call it g now. Okay, let's say I need g of 3. Then I'm just going to go sine negative 3. Okay, and it's going to do the property for me. Now the dilation, you have, if I wanted a vertical dilation, it's going to be a 3 multiplied by my function. So simply it's just going to be 3 times sine x. And if it's a value less than 1, half of f of x, and that's just going to be half of sine x. If we're going to do a horizontal dilation, so the value is going to be inside my function, so f of 3 of x. Again, all you have to do is copy the input inside your input. So sine 3 of x is going to be your new function, and similarly here, sine half of x is going to be your new function. So just seeing how the new function is going to write. Again, if you want to know the input and the output, just use the new function. That's what it's going to look like. Finally, we have the translation, f of x plus 3. Again, just copy your function in, plus 3. F of x minus 2, your input is minus 2, so your sine argument is going to be x minus 2. So we're going to transform a piecewise function. The reason I picked a piecewise function is that you would practice the transformations on these weird functions. You'd get used to them, so that is much easier to do with the more functions you're used to. So first, you can pause the video, try this on your own if you want to be adventurous, but I'm going to go ahead and show you step by step. So y equals to 2 f of x. This is just a value multiplied outside, so it's going to be a vertical dilation. If we go back to here, it's going to be a vertical dilation. The scale factor is going to be the value I have. And as I wrote here, you measure from the x-axis. So it's the y distance that's going to change. So you're going to measure from the y-axis. So if this is what you're going to do, is you're going to pick different coordinates and the main ones. So for piecewise functions, always pick like these corner coordinates. And the distance from the y-axis, the y-axis distance is basically a negative 2. And the way I measure it is I start from the x-axis and I measure to my point. That's what that definition means. And what I'm going to do is, because the distance here is 2, or sorry, the distance is minus 2, my scale factor is a 2. And so what I'm going to do is negative 2 times 2, and that's going to give me a negative 4. So my new value is now going to be, my new coordinate is going to be 4. We try it again. This coordinate has a y distance of 3. So we measure from the x-axis and go upwards, so that's 3. And my scale factor is 2, so I'm going to do times 2. So now my new coordinate is going to go all the way up to 6. So you can try it out for the rest as well if you want to. This is also 6. This is going to be negative 2, and this is going to be a 4, and I can draw my graph. Notice how it is a vertical stretch, and that's by definition what we expect it to happen. So the graph is actually stretching. Next, I have a negative f of x. This is a reflection on the x-axis. So what happens is every output becomes negative. So instead of negative 2, I'm going to negate the negative 2, which is going to give me a positive 2. This is going to be a negative 3, and positive 1, and then a negative 2. And then notice the reflection there. Next one is 2 of x, f of 2 of x, and what we said is that this is going to be a horizontal translation, and the scale factor is going to be 1 over 2 now. But it's going to be a, we're going to look at what it's going to look like. It's going to be a compression here and not a stretch. So what we're going to do is we're going to measure, by definition, you're going to measure the x distance, and this is measured from the y-axis. So what does that mean? It means if this is my coordinate, I want to know the x distance. Now the x distance is basically this. This is the x distance. So the distance is negative 2, and you start measuring it from the y-axis. So that's what it means. So the distance is negative 2, and so negative 2 times 1 over 2 is going to be a negative 1. So my new coordinate is negative 1. Again, in here, this coordinate has a distance of 2, and you start measuring it from the y-axis. So it has a distance of 2. Again, multiply it by 1 over 2, which is our scale factor, and that's going to give me 1. So this will be 1. This coordinate has a x distance of 6. So again, multiplied by 1 over 2, it's going to give me a 3. And notice how I'm starting my arrow from the y-axis. 3, and so on. You're going to continue. This is 8, so it's going to go to 4, and this distance is a 10, which is going to go to a 5, and this will be my graph. And notice how it's a compression. It's actually compressed, even though it's a 2 of x, but these two are different. They have different properties. And then last one, we have translations, negative 1 and a negative 2. The negative 1, be careful, we said about the signs. The negative 1 is actually and the h is actually positive, so it's moving to the right by 1. And then it's moving down by 2, so we're moving it down by 2. Similarly for the others, moving to the right by 1, down by 2, to the right by 1, down by 2, and so on. And then the last one, there's no space on the graph, so I'm just going to pretend the axis goes there, and this will be the graph. Notice how it actually looks like it moved to the right by 1, down by 2. Another way to write this, just to note, is in matrix form or vector form. So you're going to move the x-axis by 1, and you're going to move it down by 2. That's another way to describe the transformation you're going to go through. So if you have a combination of transformations, so if they have the same direction, or you have a vertical horizontal translation, the order really matters. And what you're going to use is you're going to use this general type transformation. Now I'm going to write it in terms of the letters we're used to, f of qx minus h plus k. So just to be aware, but people would write it in different forms, so just be aware of them. So first, what you want to do, if you have a combination, first do any horizontal translation, which is your h here. And then you want to do the stretch or reflection. So this is going to be your Q, and then you're going to do your A. And with them either comes a reflection, so a negative inside or outside. So 1, 2, and then 3. And then the last thing you want to do is a vertical translation, which is 4. So just to know the order of these transformation, it matters if you have a combination of them.